In this video, I'm looking at balancing redox equations, taking separate half equations for reduction and oxidation and combining them to make complete redox equations. Overall redox equations can be obtained by adding the two half equations so that the number of electrons gained in the reduction half equation is the same as the number of electrons lost in the oxidation half equation. Sometimes this happens, but when water molecules and hydrogen ions appear on both sides of the full equation, they must be cancelled out. Given two half equations, I see on the left the Fe, the ion, producing electrons being oxidized. Chlorine on the right, accepting them, being reduced. One electron provided by the ion half equation, two required by the chlorine. So what I need to do is to multiply the first equation by 2 so that 2 electrons are lost and 2 electrons are gained in the other half equation. The ion half equation doubled. Electrons produced in the ion half equation match the electrons required in the chlorine half equation. Now just add. Electrons cancel out. Atoms and charges balance. 2 times Fe plus 2 on the left, that's plus 4 altogether. 2 times Fe plus 3 on the right, that's plus 6, but then the Cl minus 2 of those, that gives me plus 4 on both sides. Another. When concentrated nitric acid is added to copper metal, copper is oxidized to a plus 2 oxidation state, and the nitric acid is reduced to nitrogen 4 oxide, that's NO2. So I've just written down here what was given. I look at my copper, all I need to do there is to balance in terms of electrons. For the HNO3, there's more work to be done. Balancing the reduction half equation for oxygen and hydrogen. I see I've got H on the left in HNO3, and I've got more oxygen. Add water to the right, that's here. Now I've got 3 oxygens produced and I've got 3 in the HNO3, that's good. However, HNO3, 1 hydrogen. H2O, 2. What I need to do is to add my other hydrogen ion here. Now looking at that, I've got a total of plus 1 charge on the left, 0 on the right. That's because an electron must have been added to this reduction half equation. For my copper, going to Cu plus 2, easy, 2 electrons produced. For my nitric acid half equation, I need to double everything to accept those 2 electrons. Now it's simply a case of adding everything together, and we've got the complete redox equation. MnO4 minus going to Mn plus 2. That's the manganate 7 ion being reduced to Mn plus 2. On the other side, Fe plus 2 being oxidized to Fe plus 3. When potassium manganate 7 is used as an oxidizing agent in acidic solution, no additional indicator is required. The reduction product, Mn plus 2, is colorless. No color is seen until an excess of potassium manganate 7 has been added, and we would see that as a faint pink tinge. Now my half equation is given here. I look at my Mn, 1 Mn on both sides, fine. 4 oxygens in the left, 4 H2O, fine. 8 H plus on the left, 8 hydrogens on the right, that's fine. I need to add 5 electrons to the left to balance this equation for the reduction process. The presence of an excess of acid for this reaction is essential, and the choice of the actual acid used is important. Usual choice is dilute sulfuric acid, H2SO4. We call that a dibasic acid because of the H2. I need a lot of hydrogen ions. I'm going to get them from H2SO4. The usual procedure is to add a standard solution of potassium manganate 7 from a burette to a conical flask containing a solution of the reducing agent, which has been acidified by the addition of dilute sulfuric acid. No indicator is required. And classically, potassium manganate 7 can be used to estimate the concentration of iron 2 ions in solution. Half equations can be used to deduce the overall equation. Now what we've got, I've been given my MnO4 minus plus 8H plus 5E minus. That will be for accepting electrons, reduction. Fe plus 2 going to Fe plus 3, I need an electron to be released there. Now, for the iron half equation, 1 electron is released, I need 5 for the manganese half equation. The oxidation half equation needs to be multiplied by 5 to give the electrons required by the reduction half equation. I've done that here, and I can see that my electrons accepted by the MnO4 minus is the same number as the ions provided by the Fe plus 2. Add everything up. I get my final redox equation. So, 5 moles of Fe plus 2 can be oxidized by 1 mole of MnO4 minus. Typical question. Given a mass of lawn sand containing an iron 2 salt, and this mass shaken with dilute sulfuric acid to dissolve, or at least dissolve the iron 2. Resulting solution required so much of KMnO4 to oxidize all the Fe plus 2 ions in the solution. We're asked to calculate the percentage by mass of Fe plus 2 ions in the lawn sand. Now, if this question was asked, it would be broken down into parts. First part, calculate the number of moles of MnO4 minus that have reacted well. I've got my volume and I've got my concentration. I can multiply together, remembering to put my volume into decimeter cube. I get my number of moles of MnO4 minus added in the titration. Use the equation to find the number of moles of Fe2 that were oxidized. Remembering that in the complete redox equation, 5 Fe plus 2 is oxidized by MnO4 minus to Fe plus 3, 5 Fe plus 3. What matters is 5 moles of Fe plus 2 for every mole of MnO4 minus used. So to get my moles of Fe plus 2, I multiply the moles of MnO4 minus calculated above, highlighted in yellow, and my answer 2.8 times 10 to the negative 3. So that's my moles of Fe plus 2. Now, to get the percentage by mass, I've got to convert moles into grams. Use the relative atomic mass of iron to convert moles into mass. My mass of Fe plus 2 is now my moles of Fe plus 2 times the relative atomic mass. I've taken that to be 55.8. That gives me 0.156 grams. Now, I've got my mass of iron 2 in the lawn sand, to express this as a percentage of the original sample. 0.156 grams of iron 2 out of, at the beginning of the question, 2.50 grams of lawn sand. Multiply by 100%, that's 3.9%. That's it. Okay, if you found that at all useful, I hope you did, please hit the like button and subscribe to be informed of more content.